Hello everyone, welcome to the next review of the Raku solutions, and today we are looking at the week number 80 and the first task, which is called the smallest positive number. So let's read the task. The task is: you are given an unsorted list of integers. Write a script to find out the smallest positive number missing. Right, so there are some numbers and we need to find the first positive numbers missing. So we neglect everything which is below 0 and the 0 itself, and after that we see that 1 is missing here, right? Yeah, so that's extremely clear what to do. Right, so let's look at the solutions, and let me start with my solution. And actually this solution is not the best solution. So it's working, definitely it's working solution, it's okay, but it doesn't use a lot of Raku features. So let's look at this. So what we have here is the missing n function. Well, yeah, the first Raku thing here is a dash in the name. So we take some numbers in a slurpy array, and we're going to modify that. So we remove everything which is not positive, all right, and we keep those inside the same variable. After that, so I want to find the missing thing. So the missing is, yeah, I don't want to go above the biggest number in this data list, and then I just scan every positive integer from 1 up to that maximum number, and I break the loop if I see that there's no number in this sequence, right? So if there's nothing there in the array. That's not optimal, but definitely it works, and for small numbers there's like no deal. So Raku ch 1. Right, so all the tests pass, and the tests are a couple of tests, 3 tests from the task definition, and actually there are some tests which so you see, so in some cases actually it's not defined, but what I've like the missing number is the first number outside of those numbers, right? So you see, so in this list there are 1, 2, 3, 4, 5, and there's no number less than 1. So the first missing, I don't know if it can be called missing or not, but the first number which is not in this list is 6. Right, so let's look at the solution. The solution by Jan Krnavek. Here it is. An interesting solution. So yeah, so basically the solution is only just basically it's one line, right? Well, one and a bit. So we test these for some examples from the task, and if you pass your own array, you can just do that. And there's another version of the main function, the multi-version of this function. Okay, so the main function, well, the main job happens here, smallest positive number. So we've got this range from 1 up to, well, basically infinity, but it's a lazy thing. And then we find the first thing that satisfies this condition. So basically, well, something, whatever, well, basically one of these is none of those. That's very clever. So none is a non-junction, and so yeah, we just compare this to all the numbers in this data array, and if there's nothing there, then we know that this is the missing number. The only thing that it's not like explicitly visible here, then that would not filter the input array. But you see, we apply this to these numbers, so yeah, we automatically skip all those zeros and negative numbers. That's extremely great. Raku 1 bash, Raku ch 1. There are some tests. Well, right. So we need to do this like this. Right, so and this obviously is the first missing number for the empty array. For example, if I will do it like this, 3 minus 4, 0, 5. So the first missing number is 2 here, right? Yeah, it is 2. Good. The next solution is the solution by Mark Anderson. Right, it's also a very compact solution, so we accept some integers from the command line. They all should be integers. And we, right, so if there's No, where do we start? We start here, right? So with, it topicalizes. So if this is defined, then it's being topicalized and something is applied. So yeah, it basically becomes this dollar underscore, but let's start with this part. This part is also a very clever thing. So we have this range. Yeah, that's the all the numbers from, yeah, this is what I did, right? Up to maximum +1. Minus, that's a set operation, minus all the input numbers. Right, that's great. And after that, if there's something left, then we can do this, right? Then we just take the minimum, well, the minimum key, but yeah, basically, yeah, the minimum value. And otherwise it's 1. So if there's nothing, so for the empty array, actually, let's start this Raku mark underscore Raku 1. If there's nothing, there's 1, and if these numbers, it should be 2, right? It is 2. That's very good. The next solution is by Markus Holzer, and right, so yeah, it's another interesting solution, but basically, yeah, it's kind of the same thing, because this one, right, well, basically, let me show it to you. Docs Raku, and if you will find this one, actually, see, so there are both in this sorry, both in the same place. So both of these are just set different operators. So set different. So yeah, we take this. The only thing is that there's no +1 here, the next to this maximum, right? So given, yeah, given also topicalizes the thing. This is the thing, and here we convert all those things from @n to integers. Probably don't need that, but nevertheless, yeah, but why do we really need that? I want to copy this as well. So, and after that we say if there are some elements left. Yeah, so yeah, in the previous solution it was with, which solved this, which answered this question, and there was dollar underscore before the question marks, right? And after that, that's exactly the same minimum key, and otherwise it's missing elements. Right, so let me run this solution from my thing. So Raku T and some same data. It should be 2. For the empty list, it should be right. But the thing is, what if? So the first missing number is 4 here. And now I include this 4 in the list. No missing elements. Yeah, so but that's not very clear from the definition. So whether should we print 5 in this 6 in this case, or we should report there are no missing elements. And yeah, this one I don't quite understand why we need that. The smallest missing element is 1. Smallest missing element is 1. So something isn't working if you do it like that. But why? Because why do we need to convert all of them to integer if they are already integers, right? Ah, no, those are strings, right? Those are strings, but this is not a conversion, right? Yeah. So if you will, for example, this, if you do it like this, you will get, you see, so yeah, it's even not a string, it's an integer string, but that's a separate question because this is a string, right? Yeah, it's not accepted. Okay, right. So this one was really a necessary thing, but it looks like it is necessary, but it doesn't look the solution that beautiful that it could be. Okay, great. So the solution works, which is really good. And we go next. The next solution is by Simon Proctor, Raku 1. So yeah, another great solution, I believe. Yeah, well, at least because of its size. So we accept all the integers from the command line. Again, we do not accept integers, we accept instr. But nevertheless, so what we do there, so we get this sequence. You see, so there are 3 dots. It's not a range, it's a sequence. A lazy sequence for all positive integers, containing all positive integers. And we take first, which is not in the list. Right, that's I think that's even better than we had a couple of solutions before, with also with none. But this is, I think, even more straightforward. Right, so Raku, Simon, Proctor, Raku, 1, and some data. The first missing number is 1 here, right? That's correct. So if I include this 1, the first missing number is 4. And if I include in this 4, the first missing number is 6, which is really good. Great. So I really love this solution. I think it's my winner, my personal winner, not necessarily the winner for everyone. But right, so we can go next. The next is solution by Arne Sommer. Here is the solution. So, okay, so what we do, we take some numbers, integer, and there's at least one of them there. We sort them, and we remove everything which is either 0 or negative, and we remove duplicates. And after that, so yeah, so expected number is 1, and this expected number is printed in the end. Well, not definitely 1, but something different. We scan all the positively sorted numbers, so all those basically input numbers. We take this current, right, and we break the loop, and we report this missing number if the current number is not the expected number. So, right, so we expect that this positively sorted array contains all the numbers from 1, 1, 2, 3, 4, 5, etc. And as soon as we see that the expected number at this position is not the one that, well, should be there, then this is the missing number. Yeah, that's a solution. Raku, Arne Sommer, Raku, 1, and again the same data. The first missing number is 1, and if I will include those, yeah, basically I can include repeated numbers. They will be skipped as well, and the first missing number is 6. Right. The next solution is a solution by Athanasius, and what we see here is, so all integers, that's right, so right, input. So, so we create a set of integers, and we define this set as, so this is a set. We create this set as a mapping of the input things to integers, right? By dictionary of the listed integers, right? So after that, yeah, that's also cool. So after that, basically that's the previous solution, right? But much more compact. So we increment the number while this number is in this set. This Unicode operator, yeah, it can be like LMs in parentheses, but yeah, this is definitely better. Good, I like this. Raku, Athanasius, Raku, 1, and again the same data. Missing number is 1, that's correct. Let's include this 1. Missing number is 4, and let's include this 4. Output is 6. Okay, yeah, good. So yeah, because yeah, here we do not limit ourselves. We just go as far as we need. Next solution by Colin Crain, Raku number 1. Here is the solution. So we take some numbers from input. We have some default input. Right, we create the lookup hash as a bag. So we create a bag and assign it to a hash, which is a bit strange for me. But nevertheless, so after that, so if this thing exists, if this thing basically doesn't exist, then we print this one, right? Because this OR will skip evaluating the second part, the second operand of OR, and we do that. Yeah, after that we exit. Okay, so OR and we do that for all those numbers. Raku, Colin Crain, Raku, 1. We need some input, and the output is this one. We include those 1 and 4. The output is 6. And if we will call that, for example, 8, the output is still 6. That's correct. That's extremely correct. Good. Right. The next solution is by Jaldhar Vyas, Raku 1. Right. So we take the numbers, we grab to keep only positives, and we also sort this. We assume the smallest number is the first one, that's right. Then we loop over integers up to the number of the elements in the array, right? And basically this is an index. Okay, so this is not the value, this is the index. And right, so it's not division, it's defined OR. So we have either this, if this, okay, so yeah, if this element is defined, but it is defined, right? Wait, because this is an index, and we scan over indices, and this index, right? So the actually this one, so I believe this /inf is only valid for the last iteration when we reach this .elms value, right? Which is definitely outside of the acceptable indices. Right, so but nevertheless, so we take this number, we subtract the smallest, and if it's bigger than 1, then we increment the smallest, and we stop here. Otherwise, we just take the next smallest. Okay, we can just run it. Raku, Jaldhar, Raku 1 input. The first number is 1, 1. This is 4, and this should be 6, and this is 6, right? Okay, so yeah, that works. That's good. Julio de Castro is here. Right, so what we do, we just immediately take the args array, and we convert these to the elements from this array to integers. We grab the positive, we sort, we remove duplicates, and we create pairs based on this. So basically we have the key and the value. The key, the next key, so we return the next key, succeeding, if this next key is not the value. Okay, that's smart. So yeah, because yeah, we expect the key and the value basically to be the same. And if we see that those are different, we just return this. Return 0, no empty slot. Say, right, so yeah, let's run this solution. So let's run this solution. Raku, Raku 1, some input. Minimum slot is 1, 1, 4, minimum should be 6. Yeah, well, this is kind of incorrect, but that's not required. That's correct 4. Okay, good. Right. The next solution, Kang-min Liu. Right, Raku number 1. Yoo-hoo. So we would take the input things, we convert those to integers, we create a set immediately, and right, we scan the integers, positive integers, and we take, well, we print the first one, which is not in the set. That's it. So simple. Maybe even you can get rid of this pointy block and just use the $_, right? Or a placeholder variable. Right, that's cool. That's very cool. Raku, Raku 1, some input. The first number is 1, 1, 4. The first number is 6. Great. So yeah, the 6, we got 6 because yeah, we lazily will do this up to infinity. Next solution by Laurent Rosenfeld. Right, no syntax highlighting due to laziness of GitHub. Right, so we take the elements or the some default, we sort them, and we only keep positive things, including 0, by the way, and we sort. Why do we need to use this? Right, and we remove duplicates. Then you scan over the indices and the result, which we're going to print if it is defined. Otherwise, it's just the last element plus 1, because this is already a sorted array. So we can assume the last element of this is the maximum. And nevertheless, so to make this defined, this result defined, what we need to find. So if this one and last, if this, okay, so if this sorted element plus 1 is less than the next element, yeah, we just saw this a bit differently, just key succeeding, do you remember that? We take that and we break the loop. And what do we take? We basically take this one, right? at the result. Okay, yeah, right. So Raku, Laurent Raku Ch 1, some input 1, 2, and 4, and yeah, sorry, 1. Right, and this is 6. Great. So yeah, probably this 6 is printed from here. Okay. Mohammad Anwar, Raku 1. Right, so we take some data with some default. The smallest positive number is the subroutine. It's here. It returns an integer, and so we take only positive of those. We return 1 if there are no positive elements. that means that minimum missing number is 1. Right, after that, we scan from 1 up to the... Basically, if it's sorted, then it's the biggest, the last number is the biggest number here, right? So that's the maximum that we have currently. And yeah, so instead of 4, you always can use a map. And we map that. Basically, we apply this function to all those numbers. And we break this stuff and return the number if this number is basically less than the next. Right, after that you remove the next. So let's run this. Raku Mohammad Anwar Raku Ch 1, Raku some input data. Oh yeah, how do we need to run this? So see, so there's the named parameter, and it's not a string, it's not a list. Yeah, that's difficult. So what we need, basically, we need to do it like this: n equals n equals n equals n equals n equals. I hope it will work. Right, so the next missing number, so if I want to include those n and 4, the first number should be 6, and it is 6. Right. Yeah, this was really a pain. Okay. Okay, the next solution, Myoungjin Jeon, Raku number 1. And here is the solution. Right, an interesting solution. It's number 1, that's correct. So there's some blog entry, and it looks like there are 2 solutions here, right? But we want this one. Oh, cool. That's the Unicode character. So we need to scan the range, and we want to find the first element, which is not. And I see, so we convert those input elements to a set. And that's actually already a golf solution, right? So, and this set should not contain, you see, so that's actually, I will skip this, I will swap that, this one should go on the left, but this one should go on the right side, but of this operator, but actually, yeah, that operator exists, definitely, and what's its alternative? Where is it? It's here. Yeah, so it's not cont, so it does not contain, right? This is the operator that it is used. Okay, and we print this first element. That's yeah, this is the solution, right? Maybe it's too many Unicode characters, but nevertheless. So Jeon Raku Ch 1, some inputs. It's not the input that I want this one, and if I will clone this one, it will not find. Why? Because that's strange. That's strange. So if I will skip 4, it should... Wait. It should work. I see that it should work. It should definitely work. So here's the solution, right? So these are... Maybe let's just take these numbers. Okay, so yeah, it will definitely print 1. But it should work. I believe it should. So, for example, if I will take these numbers, right, that well, no, I don't want this, I want these numbers, right? Let's comma separate them. And here is the numbers. Maybe some space, some air. Let's run this. Raku T. It's 4, so it's working. Why didn't it work there? I don't know. 1, 2, actually 3, 4. And if I will add 4, it should print 6. So I didn't quite understand if we take this number from the args, why didn't it work? So the same data as before. It doesn't work with this one. That's a strange thing. That's the homework for you to understand why it doesn't work. I don't understand that. What's the difference? Is it because those are strings, like something like that? Or what was that? Yeah, probably it will not work. You see? So that's the reason. And now it should be 6. So yeah, we saw this trick a bit earlier, but that's an important thing here. So it doesn't work with strings. Okay. The next solution, Roger Bell West, Raku number 1. And the solution here is basically the SPN function, which takes a list. It takes the list. Actually, these parentheses probably are required here, but you could get rid of that if you add the star here. But okay, so we take those numbers which are positive and we immediately create a set. Yeah, actually, when you see something like that, you might just miss when you look at the program that there's this small operator which is really important here. So okay, so this $R is a set, and we increment the M number, and while this exists in the set, while this number M exists in the set, we increment that. Otherwise, we just break the loop. Well, yeah, the loop is ended, and we print the number. So yeah, let's run Raku Roger Bell West Raku chair 1. We don't need anything. All those will work, and actually, it potentially will work also for the case when. Well, yeah, for the case when we have to print 6 for these numbers. Okay, good. And the last solution in the list, the solution by Ulrich Rieke. So we enter the array. As usual, we have to print E to end the input. After that, we take the positive integers, we convert it to a set, and again. So we increment the current expected element, and we check this with these LMs. Remember, this LMs is actually, this LM is this one. If it is an element of a set, and while it is, we increment the expected current element. After that, we just break the loop. Right, so let's run this solution. Raku, Ulrich, Raku, chair 1, Raku, chair 1, Raku. So, okay, so 3 minus 4, 0, 5, 2, 1, E to stop, and it's 4. Okay, good. So that was it. And yeah, and definitely this will print 6 because yeah, the loop is infinite. That was the solutions of week number 80. The task 1, smallest positive number. Yeah, that's the end of this review. Okay, thank you very much, and see you next time.